What's up, guys? Ready for your next lesson in awesome chemistry? We're going to talk today about properties of matter. There's two groups of properties of matter. Like when you look at any chemical, no matter what, water, for example, it's got two types of properties. First of all, it's got its physical properties. So physical properties are things like its melting point, boiling point, the conductivity, so how much electricity likes to flow through it, solubility, which is how much that material likes to dissolve in other things, amongst other things, also the density, like how packed together those molecules are. There's tons of different physical properties about every substance. There's also the chemical properties of the substance. For example, its combustibility. At what point will that stuff, that chemical, light on fire? Also, you can look at a chemical's reactivity. So how much it likes to react with other stuff. So those are physical properties versus the chemical properties. So there's physical properties and there's chemical properties of every single element, of every single chemical compound. Now that's not to say that chemicals can't change, though. Everything can change. And there's two different ways that chemicals can change. They can either change physically or they can change chemically. So an example of a physical change would be like if something were to melt. Water will continue with that same chemical. It's a pretty important one. Water can change physically. If you were to take liquid water and put it into the freezer, it turns to ice. But it's still water. That is what makes it a physical change. If you still have the same chemical, even if it's changed, it's a physical change. So water going into the freezer, changing from liquid water to solid water, it's a pretty big difference. Going from liquid to solid ice, that's a physical change. That it is frozen. That's a physical property. At what point does something melt, or what does something freeze? And the reverse of that, at what point would it melt? You take that water right back out of the freezer, and it turns back to the liquid water eventually. You could do the other thing too. You could boil that water and you could turn it to liquid vapor. And if you were to manage to capture all of that vapor, when it cooled off, it would turn back to liquid water. So that reversibility between how easy it is to reverse that process from solid to liquid to gas, back from gas to liquid, from liquid to solid, like changing between those states of matter really easily. That's all physical changes. Physical changes tend to be quite simple, actually. It's just a matter of energy. Chemical changes are a lot more difficult. When you chemically change something, you actually change what substance you have. In the previous lesson, I talked about hydrogen peroxide. Remember the elephant toothpaste? Elephant toothpaste it comes from when hydrogen peroxide, H2O2, breaks down into water and oxygen. That, when you go from hydrogen peroxide into two different chemicals, water and oxygen, that is a chemical change. You've actually chemically changed what that molecule is made up of. So all matter is broken into, all matter has two different types of properties. Its physical properties and its chemical properties. All matter can change, and it can change in those same two ways. It can change physically and it can change chemically. So let's have a look at some of those changes, because they're generally pretty fun. Again, everything has physical properties, everything has chemical properties. Everything can change physically and everything can change chemically. So I've got this happy jar of something quite familiar to you guys. This is laboratory grade sugar, sucrose, right there. That is sugar. Sucrose is made of 12 carbon 22 hydrogen, and 11 oxygen. So every single molecule of sucrose, the stuff you put in your coffee, at least I put in my coffee, is 12 carbons, 22 hydrogens, and 11 oxygens. All right, so I'm going to take a clump of this sugar, and I'm going to put it on a hot plate, like so. So we've got a clump of sugar right there on the hot plate, and we're going to turn on the temperature. Going to turn up the hot plate, and we'll observe what happens. So while this is cooking up, one important thing to note, it is it gets pretty hot relatively quickly. The hot plate, cool to the touch right now, already getting nice and hot. Watch what happens to the sugar. Again, everything has different physical and different chemical properties. So the sugar will start receiving the heat from the hot plate. And then some magic happens. We're going to start seeing some physical changes, and we're going to start seeing some chemical changes. There we go. You can start to see here that the sugar is starting to melt. That's a physical change occurring in the sugar. It's still sugar, it's just received so much energy that now it's turning to liquid sugar. All over, it's all turning to liquid sugar. So it's still sugar though. Now you'll start noticing over here particularly that it's starting to turn brown. Now it's starting to chemically react with the air. That is a chemical change. So we've got a physical change first, and when it turns to a liquid, and then it starts chemically changing as it turns to, or as it starts chemically reacting with the air, and then it starts burning. Burning is a chemical reaction. Every chemical has physical and chemical properties. As you saw with the sugar, it has one of its physical properties is that eventually it melts if you add enough heat, and then eventually if you continue to add heat, it starts chemically reacting with the air. So there's two types of changes there. I showed you a physical change and a chemical change. If I were to cool off that sugar right when it hit the melting point, right when it started turning to a liquid, it would turn right back into sugar. In the same way that if you were to cool off water, it would turn right back into solid ice. Cooling off the sugar definitely doesn't turn it back into sugar, because it's not sugar anymore. Now that I've left this thing long enough to cool down, the sugar, it's not sugar anymore. It's something different. It didn't just turn back into sugar. The chemical reaction that it went through when it chemically reacted with the air, that didn't reverse. It's still the same brown stuff that was created. So that's some of our evidence for a chemical change, for the fact that you have a whole new substance. When the color changes of a substance, that is your first evidence for chemical change. Another piece of evidence for chemical change is if a gas or a solid is produced. When that sugar was burning, when it was chemically reacting with the air, there was a whole bunch of gas coming off of it, you could see that smoke that started to form. That is evidence of chemical change. So when you see the formation of a solid or the formation of a gas, you have chemical change. Another piece of evidence for chemical change is if you have a change in odor. And trust me, if you were sitting in the room right now, you would know for sure that there was a change in odor. I don't recommend burning sugar, but if you've ever burned anything on the stove, you know that burning smell. When there's a change in odor, that is another piece of evidence that you've had a chemical change. Finally, the last one we're going to talk about, the last evidence of chemical change, is if there's heat given off or light. Light is another form of energy. So if you have heat or light coming off of the substance, that means that that's part of your evidence for a chemical change. Here's a fairly reliable way of determining if you've had a physical change or a chemical change. When you look at the substance after there's been a change, you think about how easy it is to reverse that process. A physical change is pretty easy. It's usually a matter of just changing the temperature. So like with water, changing it from ice to liquid to gas is just a matter of adding or removing heat. Fairly reversible. But imagine like an egg. When you cook an egg, you increase its temperature and it goes from that white or that clear jelly into that solid white. When you cool off that egg, it doesn't turn back into the clear jelly. Uncooking an egg is not an easy process, and in fact scientists have only recently really discovered how to do it. It is very difficult. It is extraordinarily difficult to reverse chemical changes. They're not necessarily impossible, but oh man, are they so much more difficult than reversing a physical change. All right, let's recap. Matter has two types of properties: physical properties and chemical properties. Physical properties are things like solubility, density, melting point and boiling point, and so on and so forth. The chemical properties are its ability to react with other things. Matter can change. It doesn't have to stay the same way forever. It can change. There's two types of changes that matter can go through. One of them is a physical change. So its physical properties have changed. Changing water from liquid water to solid water is a physical change. It's still water though. If you were to change it from water, if you were to break down the water into hydrogen gas and oxygen gas, that would be a chemical change. When you chemically change it, when you turn it into a new chemical, that is called a chemical change. I also went through 4 pieces of evidence that describe to you that you have a chemical change on your hands. So one being a change in odor, like how it smells. Another one being changing color. Another one being the formation of a gas or a solid. And then finally, if heat or light is given off. Those are your evidences of chemical change. That's all for today. Thanks for watching. See you next time.